Conditional probability. Conditional probability is the probability that an event will occur given that another event has already occurred. We can determine the conditional probability using the following approach. So the probability of B given A is equal to, and we've got some notation here where we've got B and what's sometimes called the pipe symbol or a vertical line A. And that can be calculated as the probability of A and B divided by the probability of A, where, of course, the probability of A is not equal to 0 because we can't divide by 0. Or alternatively, the probability of B given A times the probability of A is equal to the probability of A and B, or A intersection B. Here's an example. A six-sided die is rolled and the top face is observed. What is the probability of obtaining a number greater than 2 given that what we're seeing is an odd number? We start off in the same way that we used to start some of our optimization problems, in that we have to define some variables that we're going to work with. So we say, let event A be obtaining an odd number, and let event B be obtaining a number greater than 2. Using the notation that we just learned, we're being asked, what is the probability of obtaining a number greater than 2 given that we have an odd number? So we're given the odd number, and we're looking for event B, the probability that the number is greater than 2. Using the formula that we were just given, we can know that the probability of A intersection B divided by the probability of A will give us the result that we're looking for. So we need the probability of A and B, and we do that separately. Probability of A and B is equal to the probability of A times the probability of B. So let's break this down. The probability of A, which is the probability of obtaining an odd number, we know there are 6 faces on the die and 3 of them are odd. So the probability is 3 out of 6 or 1 out of 2. The probability of obtaining a number greater than 2. How many numbers are greater than 2 on a die? There are 3, 4, 5, and 6. So 4 out of 6 faces or 2 out of 3. Now we can calculate the probability of A and B, which is equal to 1/2 times 2/3, which is equal to 2 over 6, which can be simplified to 1 over 3. Now we can go back, once we've got our probability of A and B, we can go back to the equation we were trying to solve, and we can now say 1 over 3 divided by the probability of A, which we said was 1/2. Remembering to solve this, we invert and multiply, so that's the same as saying 1/3 times 2 over 1, which is equal to 2/3. Now, let's tackle the same problem, but we're going to solve it using a Venn diagram. First thing we need to do is define the variables the same way we did previously. So we'll let A be obtaining an odd number, and we'll let B be a number greater than 2. Once we've defined the variables, we want to go back and look at what are we trying to solve. What is the probability of obtaining a number greater than 2 given that it's an odd number? So we need to fill in our Venn diagram first of all. So when we flip a dice, when we roll a dice, we've got 6 sides, and first of all, in group in A, we're going to put in all the odd numbers, 1, 3, and 5. In B, we're going to put all the numbers that are greater than 2, which are 3, 4, 5, and 6. And 2 gets left out in the cold. It's outside of the two A and B. Now, when we look at these, we can see that we've got a 3 and a 3 in both circles, and a 5 and a 5 in both circles. And we know that we can't have them, don't want to have them in 2 places, so we know that that is the intersection between the 2 groups. So we can go ahead then and switch it to put 3 and 5 in the overlapping area between the 2 circles or in the intersection. Now we can answer the question. So we're given that the outcome is an odd number, which means we're given the numbers are going to be in A. However, we also know that we're looking for numbers that are greater than 2. And the numbers that are greater than 2 are in the intersection between the 2. So in this case, there are 2 numbers out of the 3 that are in A. So the probability of obtaining a number greater than 2, given that we know it's an odd number, is 2 out of 3. Here's another example. A math teacher gave her class 2 tests. 62% of the class passed both tests, and 80% of the class passed the first test. What percentage of those who passed the first test also passed the second test? So this is actually a fairly tricky question. So we're dealing with 2 tests. We've got test 1 and test 2. Event A, we'll say, is passing test 1. And event B is passing test 2. However, the information we were given was that 62% of the class passed both tests. So that means the probability of A and B, or A intersection B, is equal to 0.62. And the other piece of information we're given is that 80% of the class passed the first test. So the probability of A is 0.8. We're trying to find what percentage of those who passed the first test also passed the second test. This is where it gets a little bit tricky. So what this question is really asking us is, what is the probability that a student passed the second test given that you know they passed the first test? In other words, we're looking for the probability of B given A. Remember from our previous formula, the probability of B given A is the probability of A intersection B divided by the probability of A. That's the information that we were given. So we've got the probability of 0.62 divided by the probability of 0.8, and we crunch those numbers and we get 0.775. Therefore, the percentage of students who passed the first test who also passed the second test is 77.5%. Just like we can determine conditional probability from a Venn diagram with almost no calculations, we can also determine conditional probability if we have a contingency table. Ms. James asked her class of 25 2 questions. Which do you prefer, blue, red, or yellow? Then she asked a second question, do you like summer or winter better? The results are presented in the contingency table below. If a student is chosen at random, what is the probability that the student prefers yellow given that the student likes winter best? So we're looking for the probability that they like yellow given winter. To figure this out, we're given winter, so we're going to be looking at the winter row. Once we look at the winter row, we can ignore all the other numbers outside of that row. So we're just concerned with this one row. The probability of yellow given winter is 6. And since we're constrained to just that row, we're looking then 6 out of 10, which can be simplified down to 3 out of 5. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.